Hello class, I will be working a few examples from your section 1.1 homework on WebAssign. The first example says plot the numbers on the real number line. One of the main goals of this section is for you to really comprehend the difference between negative numbers and positive numbers and where they are located on a number line. And so this may seem quite easy, but it's just laying a foundation for what we're going to do later on in algebra. Okay, so for here, your WebAssign, you'll be able to drag these black dots over to where you want them. I don't have that luxury right now, and so I'll just have to kind of point. This negative 0.4 is going to be right here because it is smaller than 0, so the smaller numbers go to the left side. Next, 0.8 is going to go right here because 0.8 is larger than 0, and the larger numbers go to the right. And then 1.8 is also larger, and it will go right here. It's not marked. We know it's right in between 1.6 and 2. The next question says place the correct symbol less than, greater than, or equal to between the real numbers. So we've talked in class about this concept of absolute value, which is the distance any number is from 0. It doesn't matter if it's a positive number or a negative number, we're still just counting the distance. So the absolute value of 18, the distance of 18 from 0 is 18 places. The distance of negative 27 from 0, or we could say the absolute value of 27, is 27 spaces away. Now that you've found the absolute value, we're going to enter the correct symbol, either less than, greater than, or equal to. They're certainly not equal, but we are going to enter this less than symbol. We're going to make sure that the open, wide part of the mouth is facing the larger number, which is 27. The next question is find the distance between A and 0 on the real number line. This is another example of just the absolute value. So I want to show you this number line. Here is negative 7 down here in the red section because it's a negative number. If we physically count the spaces, ready? 1, 2, 3, 4, 5, 6, 7. It is 7 spaces away. And the way we count using positive numbers. We don't count saying negative 1, negative 2, negative 3. Our counting numbers start at 1, 2, 3, 4. And so the distance between negative 7 and 0 is positive 7. Next, it says consider the following set. A set is a group of numbers. It says determine which of the numbers in the set are natural numbers. Okay, natural numbers are also called counting numbers. Think about when you were a little kid and, someone said, hey, count to 10 for me. You started with 1, 2, 3. It's very unlikely that you got into decimals or fractions or negative numbers. And so let's just go through each of these and check which numbers belong to the natural numbers. Negative 6. Because it's a negative number, it does not belong to the set of natural numbers. 80, yes. It is positive 80. It would take you a while, but eventually you could start at 1 and end up counting up to 80. Pi is 3.14. That's a decimal. It's not part of the natural number set. Negative 7 halves, which is a negative 3.5. Again, it's a decimal, so it's not part of the natural number set. Here's another fraction, 16 fourths, but when you simplify this, it's the whole number 4, which is a natural number. 7.5 is not, and the negative square root of 2 is going to work out to be some decimal, a negative decimal at that. And so the only 2 on this list that belong to the set of natural numbers is 80 and 16 fourths. Okay, this next question, we have the same set of numbers, except this time it says determine which of the numbers in the set are rational numbers. Now, rational numbers, and you should have already seen this in class or watched a few videos about this before you're trying your homework. Rational numbers are integers, are terminating decimals, and fractions that reduce to a terminal decimal. All right, so let's just go down the list again. Negative 6, yes. Negative 6 is an integer because integers are negative and positive whole numbers. 80, yes. Pi, the previous screen I said pi was 3.14, but it actually doesn't stop at 0.14. It goes on and on and on and on forever. It's called an irrational number because it is a decimal that never stops. So pi is not a rational number. Negative 7 halves. We said that was negative 3.5, so yes, that's a rational number. 16 fourths reduces to 4, which yes, that is a whole number as well. 7.5, that's a terminating decimal, so yes, this is part of the set of rational numbers. And the negative square root of 2, well, 2 is not a perfect square number, so if you were to type this into a calculator, you would have a really long decimal, and I'll go ahead and tell you that this is an irrational number, so that is not part of the set of rational numbers. So we have 5 answers this time: negative 6, 80, negative 7 halves, 16 fourths, and 7.5. Okay, that's all for this video. If you need more help on this homework assignment, please let me know.